Hello everyone. Today we are going to learn about method of section in truss. This method is used to find force in any member of a truss if we don't need to know forces in all the members. That is, if this is a truss, A and B are supports and P1, P2, P3 are loads acting on the truss. So, suppose we are asked or we need to calculate the forces in the members this, this, and this. Then, instead of individually carrying out calculations for loads in all the members, we can use method of section. That is, we will cut a section in this way to get the forces in the members this and this. We don't need or require to know the forces in these members, which will lengthen our problem. So one question may arise that how is it possible that we can cut a section anywhere in the truss and we can get forces? The answer is that if the truss is in equilibrium for all the original forces P1, P2, P3, then if we cut a section through it, then the sections on both sides of the cutting will also be in equilibrium. At first, we need to calculate RA, RB vertical. We can easily calculate it from P1, P2, P3 and using RA plus RB equal to P1 plus P2 plus P3 and taking moment about B, then RA into this length will be equal to P2 into this length plus P1 into this length and P3 into this length. Then we can get RA and RB. When we know RA, then by cutting the section, we will have these forces acting on our section RA, P2, for which section we are calculating the loads. We will assume that in tensile direction the load is positive. These are all acting in tensile and or positive direction from the cut section. After cutting section, we can get three equations. Summation r vertical equal to 0, summation r horizontal equal to 0, and we will take moment about point C equal to 0. when r vertical will be 0, then ra will be in upward direction, p2 will be in downward direction, force in DC will be in upward direction, and force in DE will be in downward direction. For summation r horizontal, there is no outward, no external horizontal load is acting, so DC cos theta plus DE cos phi equal to 0. And why we are taking moment about point C? The sole reason is that this member and this member is passing through point C. Okay, we can take in another way. Moment about point E equal to 0. Then what will happen? That this member and this member force is passing through point E, and so the moment of these forces about point E will be 0, and only this force in DC we will get moment. Then for m equal to 0, then RAV into L1 minus P2 into L2 plus DC force in DC into, if this is the perpendicular length, L3 equal to 0. So here we have three unknown: force in DC, force in DE, and force in FE. And three equations, so we can solve them and we can get the forces, so get to know the forces in DC, DE, DF. So this may seem somewhat theoretical, and if you have trust to follow up to this one, then we will get into some real hardcore problem. This is R.C. Hibbeler book, chapter number 3. This is our truss. Okay, and here the units are in pound and feet, so that is not any problem. You can always do these problems in kilonewton and meter format. And I will explain it to you. Problem 315. here is a support and here is a support. This is not a tough problem, but lengthy problem, obviously. And you have to practice lengthy problems with simple ones. Otherwise, you cannot solve the problem in exam or competitive exams. These are all running feet. 6 feet, 6 feet, 6 feet. So RC vertical plus RF vertical equal to 600 pound at A plus 800 pound at B plus 400 pound at J and vertical component of 1200 pound at H. What will be the vertical component? For this vertical component, this length is 8 feet, and horizontal length is, this is 3 feet. Uh, 8 plus 6 plus 4, 1800 plus 1200 into 8 by 8.54 is equal to 1800 plus 1123.6 equal to 2923.6 pound. Oh, by the way, we have to solve for the forces in member KJ, JC, CD. KJ, JC, CD. And we will take moment about point F equal to 0. Then 600 into 8 plus 8 plus 6 plus 6 plus 6 is equal to 34 plus 800 into 8 plus 6 plus 6 plus 6 is equal to 26 plus 400 into 6 plus 6 plus 6 is equal to 18 plus vertical component of this force into 6 plus 3 equal to 9, that is 1123.6 into 9, and a horizontal component of this force into 8, that is 1200 into 3 by 8 square plus 3 square, horizontal component of 1200 pound force into 8 feet, is equal to RC into 18, RC vertical into 18, 20,400 plus 20,800 plus 7200 plus 10112.4 plus 3370.8 is equal to RCV into 18. This will come out 61883.2 is equal to RC into 18, and RCV will come 3438 pound. And if RC vertical is known, we can easily find RF vertical. So if we require RF vertical, we will calculate it. Now, for calculating forces in KJ, JC and CD, we will cut a section like this, and we will assume that for this section we will formulate our equations for this section, for the left side section, and from the left side section the outward forces, that is tensile forces, are acting in positive direction. So we will assume that all the forces are tensile and these forces are positive. So for this new section, now we will have three equations, that is r vertical equal to 0, r horizontal equal to 0, and moment about which point, can you guess? Moment about which point we should take 0? Yes, you guessed correct. Moment about point C will be taken as 0 because force CD and force CJ will pass through point C, and this will leave only with force KJ to deal with. Summation r vertical equal to 0. So which forces we should take into account? Now we have here 600 pound, here 800 pound, here reaction of C, okay. So downward direction we will take negative, minus 600 minus 800 plus 3438 plus CJ plus kj will be in upward direction, so positive. Kj into, this is 8, this is 8, so 8 by 8 square plus 8 square equal to 0. Cj plus kj into 8 by root over 128 equal to, this will come out minus 2038. Similarly, our horizontal will be 0. In horizontal force, CD is acting and horizontal portion of kj is acting. As height and base is equal, so it will also be 0.7. And now moment about c equal to 0. For moment about c, we get, for downward forces, 600 into 16 plus 800 into 8 is equal to kj, and the distance from kj to point c, how will know that? This is k, this is j, or we can say that this is aj k, this is 8 8, and this is 8 8. It is right angled triangle where base and height is equal. So for ck will be ak, ck is equal to ak equal to kj. Ak and kj both are root over 8 square plus 8 square, root over 8 square plus 8 square, what's come, 64 plus 64, 8 root 2, this is 11.3. So kj into 11.3. And this equation is so simple, we can solve it fast. 9600 plus 6400 is equal to kj into 11.3. 9600 plus 6400 equal to 1600 divided by 11.3. kj equal to 1416 pound. If we divide pound by 1000, we can get k. This APS system, this is not necessary to know, but okay, for your knowledge and for solving these good problems, you can always know it. Now we assumed that the kj force is acting in positive, that is tensile direction, and our answer is also coming positive. It means force Kj is tensile. Now we have got one solution. Now from equation 1 we get Cj plus Kj into 0.7 is equal to minus 2038. Cj plus 1416 into 0.7 equal to minus 2038. Cj is equal to minus 2038 minus 1416 into 0.7 is equal to minus 3029.2 is equal to minus 3.03 K, and this is coming as negative, so this compressive force. And we have solved for Kj, we have solved for Cj, and now Cd. For Cd this will be enough. From 2 Cd plus Kj into 0.7 equal to 0. Cd plus 1416 into 0.7 equal to 0. Cd equal to minus 991 pound, or divided by 1000 minus 1 K, and this will also be in compression. So as final answer we can write that forces in Kj equal to 1.41 K tensile, force in Jc or Cj is better, Cj equal to 3.03 K compressive, and force in Cd equal to 1 K, that is also compressive. So that is a bit lengthy, na? Okay, so we'll top it up with another problem. What you do when you are seeing this problem and seeing me to solve it, you also keep a note and copy the problem, otherwise you will get bored and you will miss something important, obviously. We have solved problem 315. Now we will solve a easy problem, relatively easy problem, that is 325. This is called Fink truss. So we will solve the Fink truss, and let us write the problem first. £600 acting here, 800 pound acting here and 800 pound acting here. Ten feet, 10 feet, 10 feet. And we are asked to for forces in GF, FB and BC. So you already know that the section will go like this. At first we have to find the reactions in A and D. This is before cutting the section. Always remember that you have to find the reaction forces before cutting the section. As the load is symmetrical, 600 in middle, 800 here, 800 here, so reaction will be equally divided. RA equal to RD equal to 800 plus 600 plus 800 by 2, that is 1100 pound. After cutting the section, we will get summation R vertical equal to 0. So here it is acting 1100. So what we will get? 1100 in upward direction minus 800, that is 800 in negative direction, downward direction. GF this will all be in positive direction, assuming tensile force. Component of GF in vertical direction will be in upward direction, so there is positive sign. For fin truss, okay, important things missed. How will you solve it if you don't know the angle? Okay, GF into sine 30 degree plus BF into sine 60 degree is equal to 0. That means 300 plus GF into half plus VF into root 3 by 2 is equal to 0. Equation number 1. Summation R horizontal equal to 0. BC and no outward horizontal force. So BC, so all these members, GF into cos 30 degree plus BF into cos 60 degree is equal to 0. And can you guess with respect to which point we will take moment? Yes, this time also you guessed correct, that is point F. So moment of these forces will become 0. So this is acting as a distance of 10 plus 5. 11 into 11 pound into 15 feet minus 800 we will have to know the position of X. So another small task. This is 30 degree, this is 60 degree. Now AB equal to 10, we know AB equal to 10. BG equal to AB into cos 60, 10 into half is equal to 5. Again BX is equal to BG into cos 60 is equal to 5 into half is equal to 2.5. So BX is 2.5. So 800 plus 5 plus 2.5 minus this force BC. BC is acting this distance, and this distance is 15 into 10 30, that is 8.66 feet. Then 1030 is equal to 0. 16500 minus 6000 minus BC into 8.6 is equal to 0. We get BC into 8.66 is equal to 10,500, and BC is equal to 1212 pound, that is 1.21 K, and the force will be tensile. Now simply we have to solve the equations 1 and 2 with the help of force BC to know all the forces. From 1, 300 plus GF into half plus BF into root 3 by 2 equal to 0. From 2, 1212, that is BC, plus GF into root 3 by 2 plus BF into half equal to 0. Multiply equation 1 with root 3 on both sides, that will be 300 root 3 plus GF into root 3 by 2 plus BF into 3 by 2 equal to 0. Now equation 3 minus equation 2, GF into root 3, GF into root 3 will cancel out. 300 root 3 plus BF into 3 by 2 minus 1212 minus BF into half equal to 0, and that will give us BF is equal to 1212 minus 300 root 3 is equal to 1212 minus 300 root 3 is equal to 692 pound, that is tensile, and from 1 300 plus GF into half plus 692 into root 3 by 2 is equal to 0. That will come AF is equal to minus 1799 pound is equal to minus 1.8 K. For being negative, it will be assumed it will be compression. So questions asked: forces in GF, BF, BC. Answer is GF is equal to 1.8 K compression, BF is equal to 692 pound tension, BC equal to 1.21 K tension. If you want to cross check your solutions, you can go by simply calculating all the forces in the truss member and see that if all the answers are coming as same. And I think this will suffice, and more practice will make you perfect, as it is, as the saying goes. So goodbye for before next session comes again.